Alrighty, in this video we're going to take a look at activity 1.1.2, simple machine practice problems, and we're going to look at numbers 7, 8, and 9. Since these are all grouped together, here's the scenario. We've got a medical technician uses a pair of 4-inch long tweezers to remove a wood splinter from a patient. The technician is applying 1 pound of squeezing force to the tweezers. If more than 1/5 of a pound of force is applied to the splinter, it will break and become difficult to remove. So here's kind of what we have going on. Again, we just want to use some simple machine sketches. So in this scenario, let's say here's our fulcrum, and here's our tweezers, let's say, and here's where we've got our little splinter. So if we want to draw like a little kind of splinter there, that's fine. So here's what they go through and have, is that on a third class lever, this is going to be where your effort force is. It says the technician's applying 1 pound of squeezing force to the tweezers. The resistance force is 1/5 of a pound. So we can't go through and go any higher than 1/5 of a pound. And then they say that the length of the tweezers total is going to be 4 inches. So that's going to give us that. Now, what we don't know is what's our distance to where our effort is. Where does the medical technician have to hold the pliers? So here's what is the actual mechanical advantage of the system. Here's our formula. Resistance force over effort force. And AMA is equal to, now in this case, 1/5 of a pound. We can go through and put 1/5 on top. Or the other thing we could do as well, and the bottom, the effort force is 1. But a lot of times, I'm going to use my calculator, 1/5 of a pound gives me 0.2. So I could express this as a decimal. So I'll put or 0.2 over 1, which doesn't need to be reduced down any, but I am going to go through and match the level of precision that they go through and have for this 1 pound of force. So AMA is equal to 0.200. I'm going to add one more just for a digit, just because of the fraction, and say 0.200 to 1. So that's kind of what's going on there. Now, pretty easy scenario. So just 1/5 over 1. They gave us a lot of easy numbers on this one. All right, so now I'm going to flip over to number 9. And on number 9, using the static equilibrium equations, they want to know how far does the medical technician have to hold the tweezers to go through and keep them from being able to damage the splinter. So formula, Fe times dE is equal to Fr times dr. And I can go through and start applying some of that. So here they said the effort force was 1 pound. The distance from where the technician is holding, we don't know. Resistance force is going to be, I'm going to go ahead and use the decimal, 0.2. And then I'm going to go ahead and multiply that by 4 inches. Okay? So kind of going through my calculator here, show you kind of some of the math here. So I'm going to go ahead and take 0.2 times 4. It's going to give me a 0.8. And then, of course, if I go through and if I divide by 1, it's going to give me the same thing. So then I can go through and I can take a look at dE. It's going to be 0.8, and I'm going to put 0.0 inches. So just to go through, and you could probably get by with just 0.8 because that level is going to be 0.4. But yeah, 0.8 inches, so a little over 3/4 of an inch of the way. They got to hold the tweezers at that point to make sure they don't break off the splinter. So, all right, if you got questions or anything, this is a great way to check your answers. And if you need to go through and get help from me, let me know.